In this video, we are going to solve question number 20 of exercise number 4.1. Prove that x raised to the power 2n minus y raised to the power 2n is divisible by x plus y. To solve this, let the given statement is Pn, where n belongs to capital N, which is natural number. So Pn is equal to x raised to the power 2n minus y raised to the power 2n. Now solve for n equal to 1. So P1 is equal to x raised to the power 2 minus y raised to the power 2. It can be written as x square minus y square. Now we are using the formula a plus b, a minus b. It means x plus y or x minus y, which is divisible by x plus y. Hence, given statement is true for n is equal to 1, that is P1 is true. Let the given statement is true for n is equal to k, that is Pk is true. Pk such that x raised to the power 2k minus y raised to the power 2k is divisible by m x plus y. This is equation number first. We will prove given statement is true for n is equal to k plus 1. So Pk plus 1 is equal to x raised to the power 2 k plus 1 minus y raised to the power 2 k plus 1. After solving this, x raised to the power 2k plus 2 minus y raised to the power 2k plus 2. It can be written as x raised to the power 2k dot x square minus y raised to the power 2k y square. To make is equation first, we can add and subtract y raised to the power 2 in first term. So x square is outside the bracket and x raised to the power 2k minus y raised to the power 2k and plus y raised to the power 2k. Now x square, it can be written as from equation first mx plus y raised to the power 2k minus y raised to the power 2k dot y square. After multiplying x square inside the bracket mx square x plus y plus x square y raised to the power 2k minus y raised to the power 2k dot y square. Now mx square x plus y plus y raised to the power 2k is common, so x square minus y square. Now mx square x plus y plus y square, it can be written as x plus y and x minus y. After taking x plus y common from complete terms, there is only mx square plus y raised to the power 2k x minus y. Hence, the given statement is true for n is equal to k plus 1. By PMI, we can say that the given statement is true for each natural number n belongs to capital N.